So we're starting to get a handle on these negative exponents, and I think, it makes logical sense that, most of the time you're not just going to write something down, you're going to do something with it. And so we're going to look at what happens with negative exponents and how we use those when we do some of the operations and the laws of exponents things. And I sort of touched on this in the introduction video, but I'm going to show you some examples of how this works. So let's start out with this example. Let's start out with 3 to the negative 8 times 3 to the second power. So 3 to the negative 8 times 3 squared. Okay, so if I've got this problem here, this is multiplication. And so what we know from multiplying is that you keep the base the same, right? So we got 3 and 3, so our base stays the same. And then you take your exponents and you add them up. So this is going to be negative 8, because that's what this exponent is right here. And then we got 2, so plus 2. And the big thing you're going to have to really focus on with this is making sure that you know how to add positive and negative integers. If you're not solid on that, then if I have a video to go over that, watch that. If not, you're going to have to find some way to practice on it to get better, because you do a lot of it in 8th grade. So we've got 3 to the negative 8 plus 2. So I know from adding negative 8 and negative 2 that it's basically the same as being on a number line, right? And if you're at negative 8 right here and you add 2, that means you basically go to the right 2 places. And you know that if you're going this direction and your numbers are negative, it looks like your number is getting smaller, but it's not. It's actually getting bigger. So that would be 3 to the negative 6 power. And then depending on what they're asking you for, you might write that as 1 over 3 to the 6th, or you might just leave it as 3 to the negative 6 power. So a lot of times they're going to say, write this using a negative exponent, or write this using no exponent at all, in which case you'd have to evaluate this, or write this using a positive exponent, negative, whatever. You have to see what they're asking for. All right, another example. 11 to the second power over 11 to the fourth power. This is a division problem, quotient of powers, right? And we know that when we do quotient of powers, you keep the base the same, and then instead of like up here where you added, down here you're going to subtract. So you're going to go 2 minus 4. So 2 minus 4 is negative 2. All right, and then you could either leave it like that, or you would rewrite it as 1 over 11 squared. And hopefully you're getting a little more comfortable with seeing that now. All right, we're going to look at a total of 3 more examples. So let's look at this with variables. So if I have n to the 9th, I'm multiplying that by n to the negative 4 power. Again, it's the same thing. My common base is n, right? And then I have 9 and negative 4, and because I'm multiplying these, I'm going to add my exponents. Sorry about that. I'm leaning my hand on my screen here, and it's freaking out. So you have 9 plus negative 4. So that gives me n. And then adding, you've got one number that's larger than the other one, and the larger number is positive, it's basically the same as subtraction. So it would be like saying 9 minus 4, which will give you n to the 5th power. And because the exponent is positive, they probably wouldn't ask you to write that using a negative exponent, so you just leave it the same. All right, leave it just like that. All right, next example, and this is a tricky one. We have b to the negative 4 over b to the negative 7 power. All right, so don't let the fact that this is negative here or the fact that this is negative screw you up. It's the same process. Keep your base, and because we're dividing, we're going to subtract. So you take your top number, your numerator exponent, minus 4, and you're going to subtract your denominator exponent. Now, look at what you got here. You got everybody's favorite little thing they like to forget about. You got a double negative, because there's 2 negatives that are right next to each other. And when that happens, they turn into a positive. Okay? So this is going to, I'm going to get rid of that so you can see it. This is going to basically become negative 4 plus 7. So when I write this, negative 4 plus 7 gives me 3. So this actually winds up being pretty simple. B to the third. All right, and then for our last example, and this is a lot more indicative of sort of the kinds of things you're going to be working on, is we've got 7b squared times, and then I'm going to put these in parentheses, times b to the negative fifth power. So the 7 would multiply by anything else in here that's a constant, but we don't have any other constants in there. So the 7 is just going to stay 7, and then you multiply your b's together, so we're going to multiply this by this. So you're going to have b as your base, then you take your exponents, and because it's a multiplication problem, you add. So you're going to go 2 plus negative 5, which is going to give me 7b to the negative third power. And then if I were going to write this, and this is where you have to be tricky, notice 7 has an exponent that's not listed here, and it's 1. So 7 doesn't move. 7 stays exactly where it is, but that b to the minus third power is going to go down here, and you're going to wind up with b to the third power, and this would be your finished answer. So these are the kinds of problems you're going to see, and that you're going to have to sort of work on and try and figure that out. Because in a good way to think about it is if I just had b to the negative third, you would know that that's 1 over b to the third power. Well, I could have written the 1 here, right? And then notice that 1 just stays put. Well, it's the same thing with 7b to the negative third. That 7 is just going to stay put on top. And then that b to the negative third goes down into the denominator and becomes b to the third power. All right, so hopefully this is making a little sense to you guys. Very difficult concept to grab, but you can do it.